Hey guys, so for my chemistry final, I've decided to make snickerdoodle cookies. So we're going to dive right in and we'll talk about the chemistry in each individual step. Right now I'm going to add butter and sugar to my bowl. Butter contains roughly 80% fat and 18% water. The fat coats the sugar crystals, helping with even dispersion and ensuring the dough is smooth. The water in the butter is essential for some reactions, such as gluten formation and steam during baking. The sugar acts as a crystalline abrasive, breaking down the butter's structure and increasing aeration. It also partially dissolves in the butter's moisture, beginning to form a sugar syrup that later aids in caramelization. The end result, while mixing these two, is a mixture with small air pockets that will expand during baking due to heat and leavening gases. Now I'm going to add eggs to my mixture. The egg whites are made of mostly water and proteins, and these proteins unfold during mixing and baking, forming a mesh-like structure that help trap air. The egg yolks are high in fat and act as an emulsifier, binding the fat from the butter with the water-based components of the dough. This ensures a homogeneous mixture. The water content provides an additional moisture, which hydrates flour, dissolves sugar, and contributes to steam during baking. Eggs bind the ingredients, enhancing cohesion and contributing to the cookie's structure. Without the eggs, the cookie would lack stability and crumble easily. Now to my bowl, I'm going to add flour, baking soda, cream of tartar, and salt. The baking soda acts as a base, and when combined with the acetic cream of tartar, it undergoes an acid-base reaction to release carbon dioxide. This gas creates bubbles in the dough, which expand during baking, making the cookies light and airy. The cream of tartar provides acidity to activate baking soda. It also inhibits sugar crystallization, which contributes to the cookie's soft texture by preventing large sugar crystals from forming during baking. The salt enhances flavor by amplifying the sweetness of the sugar and the warm spiciness of the cinnamon. It also strengthens the gluten network by stabilizing the protein bonds. Flour mainly provides structure. It contains two key proteins, which are glutenin and gliadin, which form gluten when hydrated and kneaded. Gluten creates a stretchy network that traps air bubbles and leavening gases. Now in a separate bowl, I'm going to make cinnamon sugar. The sugar caramelizes during baking, forming a thin, crisp crust on the cookie surface. The sugar molecules undergo pyrolysis, a thermal decomposition that provides hundreds of volatile compounds responsible for the caramel flavor. Now, as I finish prepping the cookies to go into the oven, I'm going to tell you a little bit more about the baking process. Around 140 degrees Fahrenheit, an acid-base reaction takes place. The baking soda and cream of tartar reaction intensifies, releasing CO2 gas. This causes the dough to rise and form air pockets. At about 310 degrees Fahrenheit, a Maillard reaction occurs. This involves the reaction of reducing sugars with amino acids. This creates a golden brown crust. During the cooling process, fat solidification occurs. During this process, the butterfat resolidifies, locking in the cookie's shape and texture. Although a lot of the reactions during our cookie process were chemical changes, some physical changes still happen, such as the mixing and blending. During this process, the ingredients were physically combined, altering the texture and consistency without chemical transformation. Expansion also happened when the dough rose in the oven. Gases expand when heated, causing the food to puff up. And now, through chemistry, we have some delicious snickerdoodles.